Welcome to another teardown video. This time it is another Oxford Instruments. See, Oxford. This is called an Intelligent Level Meter, ILM 211. And look, this one was in a case, so it's looking like brand new. There's not a scratch on this one. Mint condition. Just besides, those are a little bit loose. Maybe it actually was in use, see? I don't understand this. It's like not working. Nitrogen. So you can calibrate the readout for 0 and 100%. And the same with helium, so the rate slow and fast. I got absolutely no idea how this is supposed to work and what it's supposed to do, but it can probably monitor some things. That is very useful. Oh, test 95. Relays. We can control some external relays if you connected some connectivity. Auxiliary display. This is probably display, external display, just like the other one. And this one is a little bit more advanced. You can upgrade it. Unused probe and 2 probes and the missing screw. Well, let's try the thing. Let's boot it up and see what happens. Alright, mains is applied. No kaboom. Let's try and... Ooh. So that is the problem. Just the on-off switch. So I hold it. Okay. And it's alive. And of course errors because of the sensors. I really don't see this flickering with my eyes. It has something to do with the multiplexed display. So it's obviously something you see on the camera. But yeah, there's a mechanical failure on the on-off switch. That is why this was thrown out. It's obviously too difficult to change the switch. So if this is doing something absolutely fantastic, they would have changed the switch, right? Alright, it's time for open! I just removed the 4 screws, and this one is doing it right. This is how it's supposed to be. Just push it all the way to the side, see? Now you can pull it out. So we're in. So the calibration is actually software calibration. Just push this for 0% and push the other button 100%, so you can't do this with your fingers. You need something to stick through the hole. And I can actually see some marks. Yeah, you see? So it was in use. And again, the display is multiplexed. And again, a driver for all the LEDs and the entire display. Let's look inside. It looks a lot like the other unit. Again, they place the crystal oscillator somewhere else to clock clock generation is done like this, and then this clock is running the multiplexer, and or this one is something for the display driving. It's a little bit different, but it's more the main thing is the same as the other Oxford unit. It's again the same timer, the same RAM, the same EEPROM, the same EEPROM, the same Z80 CPU, the same UART, and the same RS-232 driver. This one got like a PAL or PEAL for memory mapping, and the transformator is actually also from the same company, Electric Windings. And what I find in the analog section here is, I think they're doing the same thing with measurement is timing, again for the timer, but now it's opto-isolated. See? Nice optocouplers. And look at all those different voltages. Maybe this is needed for the sensors. So they're using a high voltage regulator. And look at that one. I don't know if it's possible to... Oh yeah, it was crusty. So this is what happens when stuff is running hot. And again, hot rectifiers near temperature sensitive capacitors. This is just how everybody likes to limit lifetime of their designs. Please don't copy that. See, again, regulators near capacitors. This is how you create hum at shorter lifetimes. I wonder what this one is called. See? Maybe we should turn it that way. What is that doing, huh? Definitely something to do with the sensor. This is just a transistor mounted on the back, so maybe this has something to do with power supply for the sensors. And I don't know if the level sensing, the kind of level sensing they're doing for helium and nitrogen, is it temperature or is it pressure, or have they got more sensors, or is it just one sensor? Because there's a calibration for 0 and a calibration for 100. It could be on the same sensor. And you would probably need more optocouplers or something. It looks like there's only, yeah, see the last sensor here? Only one. And again, 3 channels to the 3 timer inputs. I wonder what that is doing. This is for the EEPROM. It's probably for storing data or settings or something. And again, this one can also regulate something or alarm some external things. So this is why you got relays, and this is obviously so you just open it, screw in your wires and pull them out the hole here on the back. So that is actually all this thing contains. And the display is one big board that is holding everything here, and it's also holding the on-off switch. It looks like this unit got some water or moisture problems, because you can see the white stuff around. Yeah, so this is definitely a water damage. And this can also be a good explanation for why this on-off switch is not working, because it contains some delicate mechanics, and when this gets wet or rusty, it will not work. I tried to manipulate this real hard, and then it actually does work. So if I'm real mean, see, and then click the other way and hold. So yeah, just need a little bit of oil maybe. Oh, and again, the same power in 3 mains voltage selector with mains filter. They love to do that one. And again, this company just love the numbers on all special mechanics. This one is done by hand, so maybe this is an early version. So yeah, I was right about the humidity or water. Look at this. This is not so good. See some water damages. Also, you see the two sensor amplifiers. They have been replaced. Another fun thing is to see this board side by side with the VTC. Yeah, look at that. There are quite a lot of similarities in the layout and the component placements. I think it looks a lot the same. That's quite interesting. So that is the clock. Why are they using that many parts for that? This will be an oscillator and some timing counter. Let's see what this is. Programmable chip. Why is that difficult? Yep, a pair. So this is for 16V8. So this is for chip select. You can even see it's accessing address lines. So this will be the address lines here. And output enable of this, and then some data to this, and this will be the display. Alright, I don't want to say a lot more about all this. Just give you a few nice close-ups so you can have a look yourself. See ya.